Before we start with branch method, let's start with something familiar, drawing models. Okay, shade half of something. So let's draw a block, that's one hole, and split it into two, shade one half. Now, half is shaded, the other half is, let's call it the remainder. That's the remainder, and currently we have two equal blocks, yeah? Next, what's half of the remainder? So we are actually going to disregard this part here. We're going to focus only on the remainder part. And we're going to halve that. So there you go. That's half of the remainder. Question. What fraction of the total is unshaded? Well, looking at this part here, the unshaded part looks like it's half, right? But that's only half of the remainder, not the total. To consider the total, we have to look at the entire block and understand here that the fraction unshaded is actually not half, it is actually 1/4 that is unshaded. And this is kind of like what branch method is about. You are looking for fractions of a fraction. For example, this is half of a half. You get what I mean? Look at this right side here. This is a half, right? This is a half of the total 4 units. And we're looking at a half of a half. What's half of that? It's actually 1/4. So we're going to move away from drawing blocks actually. The branch method is not about drawing blocks. Why? Because as numbers get bigger, the drawing is going to get more and more headachy. Let's put it that way. Right. So let me show you side by side, model drawing and then branch method. Yeah. So first thing, let's draw one hole. And for branch method, we'll just write 1. How convenient. Next, suppose we want half of the total. Okay, being shaded green. The branch method looks like this. So the upper branch here is half, and call it G for green. The remainder is half as well. So the thing about the branch method is the two branches must come together to form one whole. So if this were 1/3, the other branch would be 2/3. If this were 1/10, this branch would be 9/10. Can you see how much more convenient that is compared to drawing 10 units? Okay, let's try something more complex. What's half of the remainder? Let's shade it red. How do we show that on the branch method diagram? Just branch out from the remainder, which is this part here. We're going to branch out and say half of that was shaded red. And what's remaining? Half of the remainder. Okay. Now what's another half of the remaining at this point? So from this half here, we're gonna shade half of it in olive. Okay, and this is how it looks like. Now I can keep doing this 5, 6, 7 times. And it's really easy on the branch method. All I have to do is just to draw branches. Whereas here, it's going to get quite painful because your portions are going to get so small that it's going to be hard to see, right? So therefore, the advantage of the branch method is things get easier. All right. Now, a common question would be this. What's the fraction that is unshaded? What fraction of the total is unshaded? Well, if you have to do it on the model side, you have to split everything such that each unit looks the same. And you would end up with 8 units. But with the branch method, it's quite simple. What fraction of the total is unshaded? So I think of this as creating a connection from what you want, the unshaded part, all the way to one whole. So look at this. I will just take half of a half of half of the total. And here we're just doing multiplication. Half times half times half. Giving us 1/8. How does one go about recognizing branch method questions? There are a few words and phrases to look out for. So you will be given a fraction of something, and then a fraction of the remaining, fraction of something, fraction of the remainder, fraction of something, fraction of the remaining, and I think you know what I'm trying to say here. So when you see fraction of something, fraction of the remainder, there's a high chance it's a branch method question. And without further ado, let's try some questions with just fractions for the moment. And they are quite easy, so hopefully beginner friendly. 1/3 of the beads in the box are blue, so we are given 1/3 of the total, which is a fraction here. And here comes the key phrase. 1/6 of the remainder are yellow and the rest are red beads. What fraction of the beads are red? So fraction of the remaining and then a fraction in front, that's a clue that we are doing branch method questions. So the first step is to draw one hole, and then the first branch is 1/3 being blue. The other branch has to be one hole, so 1/3 up here, 2/3 below. And this is the remainder. Now the question says, from this remainder, draw 1/6 being yellow. So 1/6 of the total? No. 1/6 of the remainder is yellow, and the rest are red. So if one branch is 1/6, the other branch is 5/6. The question doesn't tell you, you actually have to know this yourself. And we have all three colors represented here. The question is, what fraction of the beads are red? The first answer you should not use, okay, is 5/6. This is not correct because this is 5/6 of the remainder. The question is asking what fraction of the total beads. So the way I think about it is, alright, so we want to know what's the total, yeah? And we're dealing with red over here. Mentally, I think of like a connection, like a train track, right? So imagine going here, choo-choo, and what's the link all the way to the total? It's like this. So the path goes from here to here. And which fractions did we pass by? 2/3 and 5/6. So what do we do when we are trying to find 5/6 of 2/3? We are going to multiply, okay? So fraction on red would be 5/6 multiplied by 2/3. And before we do branch method questions, you must be very comfortable dealing with multiplying fractions. So here diagonally, we're going to simplify 2 and 6, giving us 1 and 3. So numerators multiplied gives us 5. Denominators multiplied gives us 9. So the answer is not 5/6. Yeah, the answer is actually 5/9. And here we have finished the first branch method question. Let's move on to the next one. Priya had a big pumpkin. She used 1/6 of it to make pies and, key phrase, 2/3 of the remainder to cook porridge. What fraction of the pumpkin did she have left? So we'll start off with one whole. One branch is 1/6 used to make pies. The other branch has to make up one whole, so the other branch would be 5/6. And this is the remainder. We are told 2/3 of the remainder. Okay, so 2/3 of this remainder was used to cook porridge. Now if this is 2/3, the other branch has to be 1/3. And this is what we are told was left. Question, what fraction of the pumpkin, the total pumpkin, was left? Again, the wrong answer is 1/3. That's the wrong answer. So imagine the train track again. So we're interested in fraction left. So we have to imagine the train track going like this. Choo-choo, all the way to the total. And what do we do with these two fractions? We multiply them. So the fraction on the pumpkin would be 1/3 of 5/6. Can we simplify diagonally? No. So multiply the numerators, we get 5. Multiply the denominators, we get 18. So 5/18 is the answer. The bakery made some cookies. 3/4 of them were sold on Monday. 1/3 of the remaining were sold on Tuesday. Okay, so 3/4 on Monday. The other branch has to be 1/4. 1/3 of this remainder was sold on Tuesday. So 1/3 of this remainder on Tuesday. The other branch, because 1/3 is up there, 2/3 has to go down there. All right, so what fraction of the cookies was sold on Tuesday? The wrong answer would be 1/3. And again, using the train tracks mentality, all right, the imagery, imagine it going this way and connecting all the way to the total. So what are two fractions we pass by? 1/3 and 1/4. What do we do with them? We multiply. So on Tuesday, it would be 1/3 of 1/4. And the fraction we want is 1/12. Sydney gave 1/3 of his stickers to Andy. He then gave the key phrase again, 3/4 of the remainder to Alex. Okay, so 1/3 to Andy. The other branch is 2/3. This is the remainder. 3/4 of this remainder given to Alex. So AL, 3/4. If this is 3/4 up here, it's 1/4 down there. Part A, what fraction of Sydney's stickers were left? So we are interested in this, right? The fraction that's left. So by now you should know the worst answer to give is 1/4. No, what fraction of the total? So let's do the linking, which is 2/3 multiplied by 1/4. So to answer part A, it is 1/4 of 2/3. Does it matter if you take 1/4 times 2/3 or 2/3 times 1/4? It doesn't matter. The answer is 1/6. Given to Alex, what fraction? So the worst answer is 3/4. Nope, it is 3/4 of 2/3. So the connection goes like this. Alex to the total is going to pass by these two fractions. And we will multiply, giving us half. Audrey had some money. She spent 5/6 of it on a dress. So 5/6 of it on a dress. The other branch is 1/6. And 3/4 of the remainder on a skirt. So 3/4 of the remainder on the skirt. She saved the rest. So without being prompted, we must know that if 3/4 is up there, what's below has to be 1/4. And this is the fraction that's left of the remaining. So what fraction of her money did she spend on the dress? Okay, so dress is right here. How does it connect to one whole, the total? It's just like that. Did it go through any fractions? Nope. So for part A, the answer is simply 5/6. No calculation required. Next, what fraction of the money did she spend on the skirt? So looking at this, the skirt, the connection goes like this. Skirt all the way to the total would pass by these two fractions. So we are going to multiply 3/4 and 1/6, giving us 1/8. What fraction of her money did she save? So we're interested in this, which is what's the fraction left that would be saved. The connection would be 1/4 connected to 1/6 to the total. So the operation would be 1/4 times 1/6, giving us 1/24. Hopefully by now you're slightly more confident as to how this works. So Mr. Lim saved 1/4 of his salary. The remainder would be 3/4. He gave 5/9 of the remaining to his wife and the rest to his two children equally. So if this is 5/9 for the remainder, this is 4/9 of the remainder given to two of his children equally. What fraction did each child receive? Well, let's find out what was given to the two children, shall we? Okay, what fraction is given to the two children? It's definitely not 4/9. It is, the connection goes like this, 4/9 connected to 3/4 to the total. Okay, so the fraction given to the children would be 4/9 of 3/4, and if you work it out, you will get 1/3. Now we can form an equation after that. Two children received 1/3. And since they were given an equal share, what's one child receiving? It's this 1/3 divided by 2 into two equal shares. So again, the prerequisite for this topic is you must be comfortable dealing with fractions. So how do you take 1/3 divided by 2? You take 1/3 times 1/2, and the answer is 1/6. At a party, Maria ate half of the pizza. So that's half of the total pizza going to M, Maria. And Sissy ate 1/4 of the remainder. So 1/4 of the remainder went to Sissy. The rest was shared equally among 3 boys. This looks quite similar to the previous question, doesn't it? So the first step is to determine what fraction of the total went to the 3 boys. And the connection goes like this. What fraction went to the 3 boys? That's 3/4 of 1/3. 1/2, I mean. So on the boys would be 3/4 times 1/2, giving us 3/8. Since 3 boys received 3 out of 8, and it's equally shared, so 1 boy would require a division of 3. So 3/4 divided by 3 gives us 1/8. So the shortcut here is just to think of this as 3 units. And when you take 3 units divided by 3, that's 1 unit. Therefore, the answer is 1/8. Tariq was given 1 large pizza. That would be the 1 whole there. He ate 1/3 and gave 2/5 of the remaining. So Tariq himself ate 1/3 of the pizza, means he's left with 2/3 as the remaining. And out of this remainder, 2/5 was given to his 4 friends equally. So again, quite similar to the previous 2 questions, we need to first find out what fraction of the total was given to his 4 friends. Now the connection is from here, 2/5 to 2/3. For this question, we are not dealing with this bottom branch here. So understand that not every question will look the same, yeah? So what's the fraction of the total given to the 4 friends? That's 2/5 times 2/3. That gives us 4 out of 15. Now, because 4 friends receive this and it's equal shares, then one friend would be 4 out of 15 divided by 4. Here the numerator happens to be 4, so it's quite simple. It's just 1 out of 15. So far we've been dealing with fractions for our branch method questions, and now we're going to deal with questions with real numbers added to them. So let's see how it looks like. David saved 1/7 of his salary and spent 5/8 of the remainder. So far, quite familiar, yeah? He bought a camera with his remaining money and it cost $360. So this is where the real number comes in. The diagram looks the same, 1/7 saved, which means 6/7 remaining. Of this remainder, 5/8 on the TV. If this is 5/8, the bottom branch has to be 3/8 to form 8/8, one whole. And we are told that he bought a camera with this, plus it cost $360 actual dollars. Now, from here, we can form an equation. So one of the ways to do this, not the only way, one of the ways, is to say that these 3 units here out of 8 represent 360. So, yeah, 3 units out of 8, 360. We can find 1 unit, which means we will divide by 3. And then we will find 8 units, which means we will multiply 8, giving us 960 actual dollars. What do we have at this point then? This 960. Well, it's 8 units, isn't it? Isn't that these 2 branches, 8 out of 8? Therefore, I can say that this here, 8 out of 8, represent 960, which also means these 6 units out of a total of 7, these 6 units represent 960. So 6 out of 7 represent 960. You can find 1 out of 7, which means you will divide by 6, then multiply by 7 to get 7 out of 7. Why are we interested in this? Because the question is, how much was his salary? Which in this case would be 7 out of 7 units. So this is basically working from one branch to another branch. More to come. Next one. Toby used 1/5 to buy a toy car. He gave 1/2 of the remainder to his mother. And here we have a real number given to us. So the diagram looks like this. 1/5 on the toy car, which means 4/5 remaining. 1/2 to his mother, which means 1/2 remaining. And we are told that this 1/2 represents 200 real dollars. Therefore, this 1 unit would represent $200. Okay, these 2 branches combine to form 2/2. So what's 2/2 then? $400. From here, I would write $400 here. Why? So that we can form a new equation. 4 out of 5 units represent 400. So if 4 units represent 400, how much did he have at first? I'm interested in 5 out of 5 units. So if 4 units is 400, 1 unit you would divide by 4. 5 units, I would multiply by 5. And the answer is $500. 3 out of 11 of students in a school like rugby, 1/4 of the remaining like soccer, the rest tennis. Okay, so the diagram will look like this. 3/11 of the total like rugby, which means the remainder is 8 out of 11. 1/4 of this remainder, 1/4 like soccer. The rest, if 1/4 is up here, this will be 3/4. The rest like tennis. Now we are going to make a comparison between students who like tennis versus students who like rugby. Alright, how many units like rugby? It's actually 3 out of 11, so 3 units. But if you're comparing with students who like tennis, it's not 3 out of 11 versus 3/4. No. From here, I would make everything clear. Okay, so what fraction like tennis? It's not 3/4. It is actually 3/4 of 8/11, which is 6/11. Okay, isn't that nice? Because if rugby is 3 out of a total of 11 units, and tennis is 6 out of 11 units, doesn't that mean the difference is 3 units? The total, we are talking about the total, the same total of students, 11 units. And this is 6U, this is 3U. So the difference must be 3U. And the significance of that is, we can now say the difference of 3 units represents 348 actual students. How many are there in the school altogether? Well, we are looking for a total of 11 units. 11 units being the total. So if 3U is 348, what's 1U? Divide by 3. But we want 11U. So we're going to multiply 11, and the answer is 1276. Siti had some sweets. She gave 3/5 to Devi and 1/3 of the remainder to Pepe. So the diagram looks like this. 3/5 to Devi, the remainder is 2/5. Of the remaining, 1/3 went to Pepe, and 2/3 was left behind. Oh, now we're going to find the difference in units again. So what fraction was given to Pepe? It's not 1/3, it is 1/3 of 2/5. That means Pepe got 2 units out of a total of 15. Okay, what fraction went to Devi? We are told that the fraction to Devi was 3/5. But why should the total be 5U and 15U? We are talking about the same total number of sweets. So why don't we change denominator 5 to denominator 15? We're going to multiply by 3, both sides. Oh, now we know the difference between these two is 7 units. Okay, so 9U minus 2U is 7 units. What does that mean? These 7 units represent the 84 actual sweets. Well, the difference is 84 actual sweets, therefore 7 units is 84. How many sweets did Siti have at first? We're interested in 15 units. So that's 180 sweets, not dollars, 180 sweets. Well, for this question, you will be shown something that some of you might not be familiar with. It's the percentage sign. So anyway, 3/5 of the pens are red, okay? 10% of the remainder. Well, we're used to seeing a fraction, are we? 1/4 of the remainder, 3/5 of the remainder. What if we are given a percentage then? Well, percentages can be written as a fraction as well. So instead of 10%, think of it as 10 out of 100, which is what 10% means. Then cancel a 0 each, and then you get 1/10. Oh, then now it looks like a branch method question. 3/5 of the total are red, 1/10 of the remainder are green. So with this, we can draw the diagram. 3/5 red, the remaining is 2/5. 1/10 green, the rest 9/10 blue. And we're going to compare units again. So we are finding a difference between red and blue, yeah? So red would be 3/5. Straightforward because it's linked to the total directly. What about fraction on blue? It's definitely not 9/10. It is 9/10 of 2/5. That's 9/25. Since we are dealing with the same total, why should our total be 25 and 5? Turn this into a denominator with 25. So what we do there is say that, oh, we're going to times 5 times 5. We have 15 units out of 25. Therefore, the difference is 6 units, and that represents the 12 actual pens. So if 6 units represent 12 actual pens, how many altogether? Well, you can find 1 unit and then find 25 units, which is 50. Thomas was given money to buy Christmas presents. He spent 1/8 of it to buy a toy car and 6/7 of the remaining to buy a toy train. So quite standard looking so far. He returned the rest to his father, and we are told the amount returned was $8. So $8 was returned to his father. Right, 1/8 given to buy the toy car. The remainder is 7/8. 6/7 of the remainder on the toy train, 1/7 remaining. And this was returned, and it was $8. So this is where we actually go from branch to branch to branch. Yeah. How much did the toy train cost? Oh, actually this question is quite simple. Toy train's up here, and our real number given is down here. So if 1/7 is $8, what's 6/7? Oh, you just multiply by 6. And that's what we do for part A. 1/7 of the remainder, $8. 6/7 of the remainder, this is the remainder right here, is simply 8 times 6, 48 actual dollars. Part B. What fraction of the money was spent on the toy train? Worst answer, 6 over 7. What's the correct method? Link from here to the total. So that's 6 over 7 multiplied by 7 over 8. Answers 3 over 4. How much did the toy car cost? Now, since we are told that 1 unit is $8 here, and 6 units is $48 here, if we combine $8 with $48, we would get this part here. And that's what we'll do. That's $56. And that means 7 over 8 of the total was $56. Question, how much on the toy car? Now, if 7 over 8 is $56, what's 1 over 8? We're just going to take these 7 units, 56, divide by 7. And the answer is $8. And of course, we can trust the school system to make things interesting for us. There will be level 2 questions coming up. First one, 2/5 of the people in the stadium are men, 1/5 of the remaining are women, the rest are children. Okay, so the diagram looks like this so far. 2/5 men, 1/5 of the remaining women, the rest children. Now, out of the children here, the boys is twice the number of girls. Well, I can say let the boys be 2 units and the girls be 1 unit. Now, what does that mean? Well, we are used to having branches come out like this, right? Branches coming out like this. Well, why don't we say the total is 3 units? Okay, and boys would be 2 out of 3 units. Because we're dealing with children here, right? All the boys plus all the girls would be the children, which means 3 units in total for children. And 1 unit out of 3 would be the girls. Okay. If there are 220 actual girls, okay, now what can we do here? Well, if 1/3 were girls, and that's 220, we can find the total number of children, which will be 3 out of 3. So let's take 1/3 times 3, 220 times 3. Where can we write this 660? It has gone from this branch to this branch, which means now our new equation is 4 out of 5 units, 660. 4 units, 660. Well, what's the actual number of women then? Well, if 4 units is 660, what's this? Women. It's 1 unit out of 5. So 4/5, 660, 1/5, 165. That's your first level 2 done. 4 over 7 of a square is painted green, 5 over 6 of the remainder is painted red. So, pretty standard looking question so far. 1 whole as a total, 4 over 7 green, the remainder is 3 over 7. Of this remainder, 5 over 6 red, the rest 1 over 6. If the green part is 36 square centimeters more than the red part, so we are comparing units again. So what fraction was painted red? It would be 5 over 6? No, it's 5 over 6 of 3 over 7. That means it's 5 units out of a total of 14 units. Well, what fraction was green? It's 4 over 7, yeah, but the total should not be 14 and 7. They should be the same. So let's turn the total units to 14 units. The equivalent fraction is 8 over 14. Now let's compare the units, which is 3 units. The difference is 3 units. And that 3 units would represent 36 actual square centimeters, which means the area of the square is 14 units. So 14 units would be 168. Nadine spent 3/8 of her salary on food and 1/3 of the remainder on transport. Then she shared the rest equally with her siblings, such that each of them received 1 over 12 of her total. Well, let's start off with the first few sentences, easier to digest. So 3 over 8 on food, the remainder is 5 over 8. Of this remainder, 1/3 on transport and 2/3 on Nadine herself. Remember, the keyword here is shared equally with. Nadine herself had a share. Nadine with an unknown number of siblings. Okay, let's solve one part of the question first, which is what's going to be shared? It's not 2/3. What's going to Nadine and siblings? It's not 2/3. It is 2/3 of 5 over 8. And we just realized that it's a total of 5 over 12. Okay, how many siblings does Nadine have? Well, we are told that these 5 over 12 units would be shared in such a way that each person would receive 1 over 12. So what's another way of thinking about 5 over 12? Isn't it 1 over 12? 1 over 12, 1 over 12, 1 over 12, 1 over 12, 5 times? So if 1 over 12 went to Nadine, how many 1 over 12s are there left? Okay, that's 4. So how many siblings does Nadine have? It wouldn't be 5, it would be 4. So the first answer is 4. Okay, each share being 1 over 12. Given that Nadine and her siblings received 208 each, whoa, that means 5 units here represent 208 times 5 because each represented $208. So therefore, what's 2/3 here? 2/3 would be 208 times 5, 1040. How much money did she spend on transport? Well, luckily for us, 2/3 here would be 1040. Transport is simply 1/3. We'll just half the answer right here. So 2 units out of 3, 1040. 1 unit out of 3, we'll half that, giving us $520. A group of pupils learned to play musical instruments during passion pursuit. 2/5 of them learned to play the guitar, well, pretty standard so far. 1/4 of the rest, well, they didn't say 1/4 of the remainder, but basically that's the same. Learned to play the drums, with an S here actually. All the remaining pupils learned to play the recorder. Okay, so 2/5 on the guitar, 3/5 left, 1/4 on drums, and 3/4 on the recorder. A total of 255 learned to play the guitar and the recorder. Well. What fraction learns to play the recorder? Hey, that's actually the easy question. So on recorder, okay, for the love of pineapples, don't say 3/4. It is 3/4 times 3/5. So that's 9 over 20. Alright, what fraction learned the recorder? Well, we just found out it's 9 over 20, meaning 9 units out of a total of 20. Well, what fraction learned the guitar? It's 2/5, yeah. But why should the total be 5 and 20? Let's turn this into 8 over 20. Oh, that means these 2 units added together, which is 17 units, would represent 255 actual pupils. Why? Because this is the number, fraction that learned the recorder, the fraction that picked up the guitar, 17 units, in total, 255 pupils. Well, with that, we can form an equation. How many pupils were there in the group? So we're interested in 20 units, therefore, 300 is the answer. Ken spent 1/4 of his money on 15 calculators and 31 pens. Wow, straight away the question looks pretty scary because we have 2 unknowns here. Next, the cost of a calculator was 3 units and the cost of a pen is 1 unit. Wow, that's a relief. Okay, so we can assign units now and we just work with units. We don't have to work with 2 unknowns. Alright, so the first step would be to make things clear. 1/4 on 15 calculators, 31 pens. The other branch would be 3/4. He bought some more calculators, okay, an unknown here, with 3/4 of his remaining money, which means the other branch here would be 1/4. How many calculators did he buy altogether? Well, this could be a trap and potential for careless mistakes. Look, we are looking at calculators altogether. So bear in mind that whatever we found here, we have to add 15. Okay, so let's try. What's the first thing that we're going to do? We're going to say that one calculator, let's have it be 3 units. Right? Calculator, 3 times of pen. Pen will be 1 unit. Okay, 15 calculators therefore will be 45 units. And 31 pens therefore will be 31 units. So what can we do here? We can say therefore that 1/4 of the total amount of money would afford us 45U plus 31U, that's 76U. So how many units would 3/4 get us? That's 228 units. That we can write over there. Well then, this unknown number of calculators, right? 3/4 of this 228 was spent on buying calculators, 3 units each. So what is the number of units spent on additional calculators? That will be 3/4 of 228, which is 171. Well, 171 is used to buy calculators at 3 units each. So how many additional calculators is that? 57. Well, how many calculators were bought altogether? That's 57 plus the 15 at first, giving us 72 in total. David, Leon, and Felix had some stickers. After David gave 3/8 to Leon and 3/10 of the remaining to Felix, all 3 boys had the same number of stickers in the end. Okay, so let's have the diagram first. David started out with an unknown. 3/8 went to L, left with 5/8. 3/10 of the remainder went to F, and 7/10 of the remainder was left. This is what David had left after giving to his 2 friends. Okay, so let's find out what fraction David had left. It's not 7/10, it's 7/10 of 5/8. He had 7 units after that. If we are told that all 3 boys had the same number in the end, doesn't that mean that David had 7U in the end, as well as Leon and Felix? They all had 7U in the end. Okay, so what's the fraction given to Felix then? It is 3/10 of 5/8. That's 3 units. Well, let me draw a little diagram here to illustrate what's happening. That means if he is also left, Felix, if he also had 7U in the end, and we know that he was given 3 units, does that not mean that he had 4 units at first? So keep that in mind for the moment. Right, what was given to L then? 3/8. Well, we are working with 16 as the denominator, so we're not going to use 3/8, we're going to use 6/16. Well, if Leon also had 7 units in the end, and we know he was given 6 by David, does that not mean he had 1 unit at first? So F before must be 7 minus 3, 4 units, 4 or 16 at first. Leon before must be 7 minus 6, 1 unit at first. Well, we're going to read the question requirement. Ratio of L at first to F at first. Well, L at first would be 1, F at first would be 4. The ratio is hence 1:4. 7/9 of a square is colored purple. The liar wants to cut half of this part here into smaller pieces such that each piece is 3/25 of the whole square. Okay, now 7/9 will be purple. Now I know we are used to seeing branches coming off the bottom here, yeah? But if you read the question carefully, she wants to cut half of this part. So actually, the branches here appear on the top. Yeah. So half of this part here would be cut, which also means the other half would not be cut. Well, what fraction is about to be cut? And we're going to ask ourselves, how many 3/25s can be obtained from the portion that's to be cut? Because each piece is 3/25. So think of it as 3/25, 3/25, 3/25. How many 3/25s in this? So, well, to be cut, what's it? It's definitely not half. What fraction of the total is going to be cut? It's half of 7/9. 7/9. Well, that's 7/18. Okay, how many 3/25s are there in this? Because that's what we're going to cut, right? Pieces of 3/25. So how many 3/25s do we have here? It's like asking how many 2s are there in 10. It's a division problem, isn't it? So we're going to take 7/18 and ask ourselves, how many 3/25s are there in 7/18? It will divide. And we will change the division to a multiplication and flip 3/25 to become 25/3. Working this out, you would get this mixed number right here. But the question is asking, what's the maximum number of 3/25s? Well, we have 3 pieces, 3 complete pieces of 3/25. Therefore, the maximum is 3. Okay, this is an incomplete piece of 3 over 25. So the maximum number is Mr. Lee had some donuts. He sold half of it in the morning and 1/12 in the afternoon. So far, pretty tricky already. Do you realize that this is half of the total in the morning and 1/12 of the total in the afternoon? It is not mentioned here 1/12 of the remainder. So right there is a trap for most students to fall into. Okay, so how would that be done then? Okay, the first thing I'll do is to understand that the first branch is not so straightforward. I have to combine what's sold in the morning and what's sold in the afternoon, which means I know that 7 over 12 of the total was sold in the afternoon and the morning, which means the other branch will be 5 over 12. It will be a complete mistake to write half here and then write half here and then branch out 1 over 12, 11 over 12. Because this is not 1/12 of the remainder. Okay, from here, in the evening, 3/10 of the remainder was sold. Right here, this is the remainder right now. 3/10 of it. Okay, so this is just a calculation. And this is how we obtain 5 over 12. So from here, the remainder, 3/10 got sold in the evening. Which means 7 over 12, 7 over 10 left. Just before he closed shop, he sold 4 over 7 of what's left. So from here, 4 over 7 was sold during the closing time, leaving 3 over 7. Then we are given a real number to work with, 18 donuts left. So that's 3 units left. Okay, how many donuts did he have at first? Well, I can foresee that you can go from this branch to this branch to this branch back to the total. That's one method, the slow method. There's a faster method, but for now, let's have something simple first. That means 3 over 7 is 18. Yeah, we are just told here 3 units out of 7 is 18. Well, let's find 7 over 7, which is these two branches combined. That's 42. That means we can write 42 right here. Meaning we have a new equation now. 7 units out of 10 represent 42 actual donuts. What's 10 over 10? That's 60. Okay, which means we can go up here, 60. Which means new equation. 5 over 12 units represents 60 real donuts. Donuts at first would be 12 out of 12. So this is the final branch here, which is 12 out of 12. And that would be 144. Uncle Jed had some eggs. He sold 3/5 of them on Thursday and 2/3 of the remainder on Friday. He's found that he had sold 75 more eggs on Thursday than on Friday. So we are taking the difference here. So what's sold on Thursday? 3 over 5. Quite obvious. What's sold on Friday? Definitely not 2/3. It is 2/3 times 2/5, meaning 4 over 15. And again, why should the total be different? 15 versus 5. So let's turn that into 9 over 15. So the difference here is therefore 5 units, representing the 5 units would represent the 75 here. How many eggs did he have altogether? No. How many eggs did he sell altogether? I think this is where most students will get the question wrong, get the answer wrong. So if 1 unit is 15, how many eggs did he sell altogether? How many units are we interested in? What was sold? And what was sold was 9 units and 4 units. So the fraction sold was actually 13 units. Therefore, the eggs sold would be 13 times 15, 195. So this is level 2 because most students are used to finding the total, but in this case, it's not. Now we proceed on to level 3. So hold on to your pens and here we go. Contestants in a quiz were awarded certificates based on their score. So distinction, 3 points, okay, and so on and so forth. A total of 312 points were awarded. So far, it doesn't look like a branch method question, does it? 1/8 received this distinction. 4/5 of the remaining. Well, there we go. Okay. So first thing we do is 1/8 distinction, 7/8 remaining, 4/5 of that remaining merit, 1/5 participation. Okay, so number of distinctions, 1/8 of total. Merit would be 28 out of 40. So by now you should know that I don't want to work with 1/8 anymore. I want to work with 5/40. So very clearly at this moment, I can see 5 units for D, 28 units for M, 7 units for P, total 40 units. Okay, so 312 points were awarded though. How do we find out the number of contestants? So we know that each distinction carried 3 points, merit 2 points, and so on and so forth. And we are told that there are 5 units of distinction winners, and so on and so forth. Okay, that means this is 12 units, 15 units, sorry, 56 units, 7 units, and that represents 312 points in total. So pretend these are 5 students, right? If each of them scored 3 marks, you get 15 marks. Unfortunately, these are not 5 students. These are 5 units of students. We don't know how many that is. But we do know everything here adds up to 312 points. Well, let's form an equation then. 78 units is 312 points. 1 unit is 4. Wait a minute. 1 unit is 4. We can find the actual number of students now. How many received distinctions? If 1 unit is 4, then the number of students who got distinctions would be 20. 5 units times 4. That's 20 actual students who scored distinctions. And that's your first level 3. Mr. Chin had some money to spend on a vacation. He spent 0.6. What a strange way of writing this, 0.6. Hey, we are used to fractions, so give us fractions. No, life is not so easy. Okay, and 5/8 of the remaining. Hey, that's the key phrase right there that tells us it's a branch method question. Then the question proceeds to give us a percentage, which we should convert to fractions. So these two, we have to convert to fractions. And let's do exactly that. 0.6 is written as 6/10, which is 3/5. 12% is written as 12/100, which is 3/25. So now we can make it look like a branch method diagram. So 3/5 on air tickets, 2/5 left. 5/8 of the remainder on accommodation, 3/8 left. Then 12% of what he had left. Well, you can either write 3/25 or you can write 12%. Now, knowing that the total has to add up to 100%, this is 88%. And we are told the actual savings. We can form an equation with that. So how much money did he have at first? Well, we can go from branch to branch to branch. Yeah, the slow method. 88% is 2112, sorry. 1% is 24. 12% is 288 on gifts. 100% is 2400. Well, what do we do with the 100%, which constitute this branch right here? Which means 2440 can be written right here. So new equation. 3/8, 2400. What's 8/8? These two branches added together, 8/8. That's 6400 right there. New equation. 2/5, 6400. How much did he have at first? We are interested in 5/5 then. So that would be $16,000. Done. What percentage of his money on gifts? Well, we are told that what's on gifts is simply, well, there are a few ways to do this. We have just found the actual amount of money on gifts. We can just take that and write the denominator as $16,000 and then find the percentage. Alternatively, we can use the branch method. 12%, connect all the way to the total. Yeah, so the journey goes like this. 12% of 3/8 of 2/5, which is exactly what's done here. The answer is 1.8%. Express the amount of money on gifts. Okay, so on accommodation, therefore, is 5/8 of 2/5. That turns out to be 25%. Okay, so if what's spent on gifts as a percentage of the money on accommodation, you see the word "of" here? This tells me accommodation would be the denominator. So 25 units here, denominator. And what percentage of that on gifts? So that's 1.8. Meaning 1.8 over 25 times 100, that gets us 7.2%. School A had a fundraising activity. 2/3 raised by P6, the rest by P3. So we got two different levels here. So 2/3 by P6, which means the rest 1/3 by P3. 5/12 of what was raised here was by boys. So, okay, we can form a branch here, 5/12 by boys. Now that automatically means 7/12 by girls. And 1/3 of what was raised by P3 was done by boys. Okay, boys, 1/3 by P3, which means 2/3 by girls. From here, we can tell all the girls raised $4,950. Well, what fraction was raised by girls? Remember, girls, P6 girls as well as P3 girls raised 4,950 altogether. Okay, so from that, we can say, what fraction all girls? That would be 7/12 times 2/3. Those are the P6 girls. Plus 2/3 of 1/3. That's the P3 girls. And that means we have 7/18 plus 2/9. Combine them together, we will obtain 11 units out of 18. Now remember, these are 11 units all girls, P6 and P3. Out of 18 units, the total students involved here. Okay. We are told that all the girls raised 4,950, which means how much was raised by all the pupils? That's $8,100. We are interested in 18 units. By the way, if 11 units by girls, doesn't that mean 7 units by boys? Because the total is 18, right? So let's keep that in mind. Part B, what is the difference between that raised by boys and all the girls? Oh, so all the boys must be 7 or 18, as I've just mentioned. So if the difference between boys, 7 units, and girls, 11 units, is 4 units, and we are told, okay, when we have the total amount of money left, that means 4/18 of that total sum would give us the difference in terms of money. Hawker Han spent 2/3 of his money on 3 kg of meat and 9 kg of fish. Goodness me, there are two different unknowns over here. Oh well, it's gonna be a head scratcher, this one. 2 kg of meat costs as much as 3 kg of fish. Oh, okay, that's slightly more useful. And this is where it looks like a branch method. 1/4 of its remaining on vegetables and 81 left. Well, how would the diagram look like? 2/3 on 3 kg of meat, so I'll call that 3M for simplicity's sake. 3M plus 9 kg of fish. Alright, which means the other branch is 1/3. Then 1/4 of that remaining on vegetables, and 3/4 left, and that's 81 actual dollars. Okay, what do we do with this info? Look at this. 2M is equal to 3F. Well, we can do something about that. 2M equals 3F. If I times 3 on both sides, I'll get 6M equals to 9F. Now, why would I do that? Because I don't have to write 9F anymore, do I? I can just work with one unknown, which is 9F equal to 6M. We can say, therefore, that 3M plus 6M is equal to 9M. So we can say that, therefore, 2/3 represent 9M. Anyway, the first question is quite easy. What fraction was left? It's just 3/4 times 1/3. Okay, now to the tough stuff. So if 3/4 represent 81 actual dollars, what's 4/4 going to represent? 108 actual dollars. So we can write this here. So if 1/3 represent 108, 2/3 represent $216. Why is that useful? I can therefore say 9 kg of meat cost 216 actual dollars. Well, looking at this, we're interested in 1 kg of fish though. So having found 2 kg of meat being $48, doesn't that mean I can say 3 kg of fish costs the same as 2 kg of meat, which means 3 kg of fish cost $48. So that's the equation I would use, and therefore 1 kg of fish would be 48 divided by 3, 16 And this brings us to the merry end of this exercise. Hopefully you have found this useful. Ta-ta!